Objective 1.6, the quadratic formula. In this lesson, we want to solve quadratic equations using the quadratic formula. We want to be able to give solutions as simplified exact answers. And we want to use the discriminant to help us determine the number and types of solutions that we should get. So when we look at the vocabulary, we see the actual equation that is used as the quadratic formula. This is an equation that you must memorize. If you haven't done so already, you need to commit this to memory. It should be one of those equations that you can just say off the top of your head practically in your sleep. Just like y equals mx plus b, a squared plus b squared equals c squared, and opposite of b plus or minus the square root of b squared minus 4ac all over 2a equals x in the quadratic formula. Okay. The expression b squared minus 4ac, which you see right here inside of the radical, that is called the discriminant. Okay? And the discriminant can tell us what kind of solutions to expect and how many of them. So when that discriminant is greater than 0, so when we get a positive answer, then we know we're going to get 2 real solutions. If we end up with that discriminant being equal to 0, then that tells us we're only going to get 1 real solution. And if the discriminant ends up being negative, less than 0, then that tells us our equation has 2 imaginary solutions. So as you are setting up your quadratic formula, you can look at your discriminant midway through the process to give you sort of a forward look of what to expect for your solutions, and use that as a quick double check. All right, so at this point now, we have several methods for solving quadratic equations. We've talked about being able to factor quadratic equations to solve them. We've talked about finding square roots. We've talked about completing the square. And our fourth and final method is going to be using the quadratic formula, which is actually just a shortcut of the completing the square method. So let's use this in our first example. We're trying to solve x squared minus 9x plus 5 equal to 0. So in that equation, we need to identify a, b, and c. And in this case, we can see that a is going to be 1 because there's no actual coefficient written in front of x squared. We can identify the b as being negative 9 because that's the coefficient on x. And then c is our constant, and in this case that's going to be positive 5. So once we know what a, b, and c are, we're ready to substitute into the quadratic formula. So x is supposed to be equal to the opposite of b. b was a negative 9, so that goes in there. Plus or minus the square root of b squared, so again we put b in to square it, minus 4 times a, which was 1, times c, which was 5. And then all of that goes over 2a, and again a was 1. Now, when you are setting these up, you don't need to be quite this minute about how you're setting it up, but this is the thought process you should be going through. This is what you should be doing, even if you're simplifying a little bit along the way. But I would recommend that you don't simplify too much along the way, that you really just get everything set up before you simplify. And then, to start the simplifying process, I would highly recommend that you start inside the radical, because that's really going to be the key to what happens next. Okay, so if we simplify inside the radical, we see that my negative 9 squared gives me the 81, and then the 4 times 1 times 5 gives me 20. So I'm looking at taking 81 minus 20, which becomes 61. Also notice there that when I take the opposite of b out in front, that opposite of negative 9 became positive 9. And my 2 times 1 in the denominator just became 2. So I'm now looking at 9 plus or minus the square root of 61 over 2. Now here's a good place to stop and talk about the discriminant for a minute. We said the discriminant was that b squared minus 4ac part of the formula. So it's that part that's inside of the radical. And that has been simplified to a 61. That 61 is greater than 0. And so because of that, we know that we should end up with two real number solutions. They may not be pretty real number solutions. They may end up irrational. They may end up with radicals in them. But we're going to get two real number solutions for this equation. Now, how do I check that my final answer is simplified and exact? Well, the exact part is fairly easy. The exact part means that we want to leave it in radical form if appropriate. Or in other words, we do not want to decimalize. I do not want you to punch the square root of 61 into your calculator and turn it into some decimal, because you will have to round it. The square root of 61 is irrational. There is no terminating decimal that it's equal to. So as soon as you stop writing, you have rounded it, and it's no longer exact. So in order to keep it exact, you leave it in radical form. Now the reason I say if appropriate is because if this is the square root of 64, where 64 is a perfect square, then obviously we want to take the square root of 64 and just make it 8. But if you're trying to take the square root of something that's not a perfect square, then you just leave it in radical form. So that's the exact part. Now, how do we know if it's simplified? Well, it really all hinges on the square root. So here's a little chart that you can use to help you know if you have an answer that's simplified. You start out by, let me back up. You start out by asking yourself, can the radical be simplified? Can that square root of 61 be simplified? Well, going back to our previous lesson, we know that it can only be simplified if it has a perfect square factor. And in this case, 61 does not. So if you answer no to this first question, then you are done. Your entire answer is as simplified as it can possibly be. Don't try to make anything else happen because it can't. If you cannot simplify your radical, you cannot simplify anything else, and you are done. Now, if your answer is yes, then you need to go ahead and simplify it. So if this had been the square root of 60, for example, we would go ahead and make that to square root of 15. Okay? Then you ask yourself, do all three terms have a common factor? So that means this number right here, whatever you end up with simplified here, and the denominator here. Now, in order to be a factor in a radical, it has to be a number that's on the outside of the radical. Okay, so that's what you're looking for a factor in the radical term. So, again, if you can answer no to that question, then again, you're done. You leave your radical in simplified form and then you stop. But if you can answer yes, then you go ahead and cancel that common factor, to get your answer into its final simplified form. So in this case, because the square root of 61 could not be simplified, our answer is already simplified as much as it can be, and we don't need to go through any of the other steps. But we're going to see examples here in this lesson where we will be going through some of the other steps, and you'll see what I mean by them. All right, let's give you a chance to practice this now. Take a minute to solve negative x squared plus 2x plus 4 equals 0 using the quadratic formula, and come back when you're ready to check your answer. All right, so in this case, excuse me, we can identify A as negative 1, B is going to be that 2 right there, and C is going to be that 4. So when we take the opposite of B, we actually end up with negative 2 because B was 2. The A right here is going to be our negative 1. The C there will be 4. And again, the A on the bottom is negative 1. So if we simplify this first, this 2 squared is going to be 4 minus 4 times negative 1 times 4 is negative 16. So 4 minus negative 16 really becomes 4 plus 16, which is why we end up with 20. This is where most students make their mistake, is they get mixed up between the minus that's here and any negative that ends up with their multiplication. They don't keep that straight. They're not careful enough with that. You really need to pay attention to that because it makes a huge difference in the kind of answer you get. So the 4 minus a negative 16 becomes 20. And then going through our little chart, 20 can be simplified. So that becomes 2 square root of 5. And then when I look at negative 2, 2 square root of 5, and negative 2, I can see all of them have a factor of 2. Or I could even say they have a factor of negative 2. Okay? But remember, it's only because of the 2 out here that I can say that in the radical term. It has nothing to do with this 5 that's on the inside. So if I divide everything by the negative 2, that ends up giving me 1 plus or minus square root of 5 all over 1, which you can see we just disregard. And so 1 plus or minus square root of 5 is our final answer. If you need a second to fix anything that you did, pause the video and then come back when you're ready for the next example. All right, so now let's take a look at this quick equation. We want to solve 2x squared minus 5x plus 7 equals x squared minus 3x plus 6. Before we can identify the A, B, and C to use in the quadratic formula, we have to get our equation into standard form, which means we have to get all of our terms on one side equal to 0 on the other side. So we can start moving things over. We can subtract the x squared, we can add the 3x, and we can subtract the 6 to end up with x squared minus 2x plus 1 equals 0. Now we can identify A, B, and C to plug into the formula, and then simplify our discriminant, which ends up being 4 minus 4, which gives us 2 plus or minus the square root of 0 over 2. Now notice the discriminant in this case. This time I end up with a discriminant of 0. What does that tell me about the answers I'm going to get? Well, if you go back to what we said in the vocabulary section, this means that I'm only going to get one real answer. Because if you think about it, the square root of 0 is 0. So if I take 2 plus 0, or if I take 2 minus 0, I get the same answer in the numerator. And when I take that answer and divide it by the denominator, either way, I get the same answer of 1. So here's an example where we can see that getting a discriminant equal to 0 ends up giving us a solution where there is only one real number solution. Okay, so your turn. See what happens when you try to solve x squared plus 10x plus 25 equal to 0. Again, pause the video for a moment and come back when you're ready to check. All right, so our A is 1, our B is 10, and our C is 25 in this case. So when we substitute our numbers into the formula, you can again see how our discriminant ended up giving us 0. So when we work it out, negative 10 plus or minus 0 divided by 2 ends up just giving us a negative 5 for an answer. If you want to see another reason why this happens, this is actually an equation that we could also solve using factoring. Because x squared plus 10x plus 25 is just a perfect square trinomial. So if we were to use factoring in this case and make it x plus 5 squared equals 0, then we can easily see how x would have to be a negative 5 in order to be a solution. And since both of my factors were x plus 5, the negative 5 works both times, and that's why we only get one solution for an equation like this. Okay? All right, let's take a look at another example. So here we're solving the equation 3x squared minus 3x plus 5 equals 0. Our A is going to be 3, our B is going to be a negative 3, and our C is going to be 5. So when we substitute that into the quadratic formula, we can work out the discriminant, and we end up with 3 plus or minus the square root of negative 51. So notice this time our discriminant ended up negative. This tells us that our solutions to the equation are going to be two imaginary solutions. Because when I'm dealing with the square root of a negative, I know I have to simplify that by bringing the I out front and getting rid of the negative that's inside of the parenthesis, inside of the radical. So now I end up with 3 plus or minus I square root of 51 over 6. So I did do a little bit of simplifying with my radical here. But now if I look at all three terms to decide if I have a common factor, the answer is no. Even though 51 can be divided by 3, 51 is still inside the radical. I cannot divide a factor that's inside the radical. So when I'm looking for that common factor to cancel, anything inside the radical is off limits. Now, if you really want to be precise about this, you could split things up and say that the 3 over 6 would become 1/2, and then the square root of 51 over 6 would be the coefficient on your I. If you prefer to write it that way, which is a more true complex number form, you are certainly welcome to. I am not, however, that concerned about that. If you just want to leave it as 3 plus or minus I squared of 51 over 6, that's fine. But you do need to make sure you deal with the negative 51 by bringing the I out in front. Okay? All right, so let's give it one more try. Go ahead and take a moment to solve x squared minus 6x equals negative 10. Pause the video one more time and come back when you're ready to check your answer. All right, so for this equation, we first need to add the 10 over so that we end up with the standard form of our quadratic equation. Then we can identify A as 1, B as negative 6, and C as 10 to put into our quadratic formula. Notice that we end up with 36 minus 40 inside of the radical, so that gives us a negative 4. That negative 4 tells us we're going to get two imaginary solutions. And the square root of negative 4 is actually going to end up with a fairly nice 2i as an answer. So because I've gotten rid of the radical here, I can now look at the 6, the 2i, and the 2 to decide if there's a common factor to cancel. And in this case, the answer is yes. I can factor out or cancel out a 2 from all of those. And so the 6 divided by 2 gives me that 3. The 2i divided by 2 gives me that I. And the 2 divided by 2 in the denominator gives me 1, which we don't really use in our final answer because it doesn't make any difference. So 3 plus or minus I should be the final answer to this equation. All right, so that should be enough information to get you through the practice problems for objective 1.6 in your booklet. Again, even if you can solve the equations using different methods, I want you to only use the quadratic formula so that you are practicing it, practicing the simplification of it, and just reinforcing, memorizing what the formula is in your head. If you have questions, make sure you're looking for the resources that will help you to answer those questions as they arise, and don't forget to check your answers once you're finished on Canvas. And that's going to do it for this lesson. We will see you next time.